Okay, let's go with example number 3, this one. If we take a look at this, these two terms are actually perfect squares. Well, why are they perfect square? Well, because if we take a square root of each of them, so let's say we take a square root of 144 x squared, we are actually going to get 12 times x. Okay, so we got 144 times x squared underneath the radical. Because we only have multiplication under the square root, we get to use the loss of exponent, and we rewrite this root into two distinct ones. One go with each term, 144 and x squared. Well, square root of 144 is 12, and square root of x squared is x. So that means 144 times x squared is a perfect square because we have a smaller term, in this case 12x, that multiplies itself 2 times to give us back 144x squared. So that's how we know that 144x squared is a perfect square. Okay, there we go. So hopefully you guys can see that. And of course, same thing for 49. 49 is a perfect square because we know square root of 49 is 7. And of course, 7 is a smaller term that multiplies itself 2 times to give us back positive 49. So yes, positive 49 is also a perfect square. So because these two terms are perfect square, we rewrite these two terms into a smaller number that is raised to the second exponential power. So basically, we rewrite 144x squared into 12 times x raised to the second power. Bring down the minus sign and then rewrite 49 into 7 raised to the second power. But hey, guess what? If you guys recall the special case factoring of quadratic equation, whenever you have the difference between two perfect squares, you're going to have a set of binomial factor. In the first set, you're going to have these two terms, and then 7 over here. Hopefully you guys can see that. Actually, I want to make it a little bigger. So in the first parentheses, you're going to have these two terms, 12x and 7. And in the second parentheses, same thing, 12x and 7. Now, what about in the middle? Well, with the special form of the difference between two perfect squares in a standard form quadratic equations, when you factor out this special form of the quadratic equation, you're keeping the two terms, 12x and 7, in both of these parentheses. And in each of those parentheses, you're going to have a minus and you're going to have a plus. Okay, so if you guys don't remember that, it's somewhere in the textbook, or you guys can look it up. But yeah, that's the idea of factoring out the special case quadratic equation. Well, more specifically, the special case of the difference between two perfect squares. Well, anyway, with two binomial factor multiplying together equals 0, by the zero product property, take each of these binomial factor and set it equal to 0 and solve for x. So we got 12x minus 7 equals 0, 12x plus 7 equals 0. We'll solve for x individually again. Got 12x equal to positive 7. Get rid of a 12. That is multiplying the x by doing the opposite of multiplying, which is dividing. Got x equals 7 over 12. And then over here, we got x equal negative 7 over 12. So two x values that can potentially be the solution of the original expression. And I'm pretty sure they are. Well, we just had to check for them. So if x is equal to 7/12, then x equals 7/12, and I'll fill out the reasoning in a little bit after I check it. Plugging in 7/12 into the original equation, what am I going to get? Well, I'm going to have 144 multiply 7/12 square minus 49. Is that really equal to 0? With a question mark. Well, let's, well, because this is fraction, you guys can go ahead and try to do mental math, but I like to write it down when it comes to working with fraction. So this is same as 144 times 7/12 times 7/12. Dropped out everything else. Well, let's see. Two fractions multiplying together. So numerators multiply together, denominators multiply together. So 7 times 7 is 49, 12 times 12 is 144. But hey, we got 144 over here, which is the same as itself divided by 1. So we have a common term, 144 and 144. Guess what? We have to cancel it out. So we're left with 7 times 7, which is 49, divided by 1, which is just 49 itself. Bring down to minus 49. Guess what? 0 equals 0. So x equal positive 7 over positive 12 is a solution. Same procedure for the other x value, negative 7/12. So if x equal negative 7/12, then x equal negative 7/12, and then I'll fill in the reasoning in a bit. I have 144, and I'm going to write 144 over 1 this time because of the fraction. Okay, but always remember that any number by itself is the same as itself divided by 1. So negative 7 square minus 49, is that really equal to 0? Well, let's do some mental math here. Negative 7/12 raised to the second power, that is the same as negative 7/12 multiply negative 7/12. But hey, that's going to give us, again, positive 49 divided by 144. But guess what? Common term 144 cancel out again. We're left with 49. Well, 49 divided by 1, which is just 49 itself. Oh, hey, we got 0 equals 0. So that means is also a solution is what we'll have to write for x equal negative 7/12. So because all of these x values, when once we plugged into the original equation, give us the give us the left hand side equals to the right hand side, meaning they are both solutions and we have no extraneous solution. All right.